In this video, we are going to be talking about an introduction to radicals and square roots in particular. So first of all, the square root symbol itself, you're probably familiar with. This is also called a radical sign. Okay, so there are other roots besides a square root, like cube roots and fourth roots and fifth roots, and all of those are called radicals. The number inside the radical is called the radicand. There are two square roots when we take a square root. So one is called the principal square root, or the non-negative square root, and that's probably the one you are most familiar with. But there's also a negative square root. And what do I mean by that? Let's go ahead and look at this example here. If you're just asked to find the square root or square roots of a number, such as 81, we are asking what times itself would give me this number. So the square root of 81, as you're familiar, the principal square root is 9, because 9 times 9 gives me 81. The negative square root means I take the square root of 81, which is 9, and I make it negative. So that negative out front is applied after you take the square root. It's on the outside. And again, that's because negative 9 times negative 9 would give me 81. That's what square root does. What times itself would give me that value? Negative 9 times negative 9 would give me positive 81. So in general, there are going to be two roots. If you're asked in words to find all possible roots, there is a positive root and a negative root. Now, if we're actually using the symbol, the radicand signs, then whatever that symbol is, that's the answer. There's only one. Okay, so here I'm taking the principal square root, the non-negative square root, versus down here in example E, I'm taking the negative square root. So with the symbols, you'll see whether or not that negative is applied. Let's go ahead and just try some examples. I have the square root of 25 here. Again, this asks the question, what times itself would give me 25? Well, 25 is a perfect square. It is 5 squared. 5 times 5 would give me 25. Now, a square root is also an inverse operation of squaring. So just like add and subtract, multiply and divide, those are inverse operations. I am squaring and I'm taking the square root. So in a sense, the square root is undoing that square, just like add and subtract. So the square root of 5 squared is just 5. In example B, we have the square root of 0. So what times itself would give me 0? That's easy. 0 times 0 would give me 0. Okay, 0 is one that would not have a principal and a negative square root, because there's no such thing as negative 0. 0 is not negative or positive. So, part C, I'm taking the square root of a fraction. So square roots of fractions, you can take the square root of the numerator and denominator separately. In this case, I could rewrite this as the square root of 9 being divided by the square root of 25. So essentially, I'm taking the square root of everything in here, or underneath that radical sign. So the square root of 9 is 3, because 3 times 3 would give me 9. The square root of 25 is 5, again because 5 times 5 would give me 25. Once you have taken that square root, we don't write the symbol anymore. So a lot of times I'll see students write the answer is the square root of 3. But to get out of the square root, I actually had to undo that square. So 9 is 3 squared. Undoing that square, I get back to 3. So once you've undone that operation, you don't write the symbol anymore. Alright, part D. I have the square root of 36, let's see, tenths, hundredths, thousandths, 10 thousandths. There is a way to do this without a calculator. you are more than welcome to use your calculator on a test or anything like that. But the way you would do this without a calculator is we have this perfect square, 36. The square root of 36 is what? Should be just 6, right? 6 times 6 would give you 36. And then we have to think about the decimals. So I have 1, 2, 3, 4 place values after the decimal. When we take the square root, we cut that in half. So if there were 4, my answer should have 2 decimal place values. So 1, 2. And so that should be 6/100ths. Now let's look at these next two. They're very similar. They both have a square root of 25, but one has the negative on the outside and one has the negative on the inside. So we've already kind of mentioned that this is the negative square root. It says take the square root of 25 and make it negative. So I have to evaluate this square root first and then apply anything that's outside of the square root. So this answer, what times itself would give me 25, is 5. And then I have to make it negative. I have to apply that negative. You could also think of this as like a -1 times that square root if it helps. On the next example, remember the radicand, the piece underneath the radical, we're saying what times itself would give me that value. So what times itself would give me a -25? Well, I could try a +5 times itself gives me +25. A -5 times itself, well, anything times itself with negatives, I have a negative times a negative, I end up positive. There's no way to multiply two values that are the same and get a negative, right? So no real number would do that. A positive times a positive gives a positive. A negative times a negative gives a positive, not a negative. So for now, we could write does not exist, or there's no real solution. So you might see some textbooks say D and E for does not exist. Some textbooks will say no real solution, meaning there are imaginary numbers that we'll talk about later that can simplify this, but there's no real number that will multiply times itself and give you a negative. So to sum it up, when we're evaluating a square root, we're asking the question, what times itself would give me that value underneath the radical sign? So you have to figure out what is being squared and then undo that square to get the answer. Pay attention to whether or not a negative is on the outside or on the inside. Nothing times itself would give you a negative, or sorry, no real value times itself would give you a negative number. This is asking for the negative square root.